Hey there, Lesson 8 in Unit 2. Unit 2 is all about congruency. Today we're just moving along with that congruency, right? So in Lesson 8, let me get to the right page. Perpendicular bisector theorem. We used that a little while ago when we were talking about isosceles triangles, and then I erased it and said, no, we're supposed to use the angle bisector theorem to get that, but today we're going to talk about the perpendicular bisector theorem. We've learned how to make perpendicular bisectors by constructing two circles that overlap and using the intersection of the two circles to draw a line. Let's see where this takes us today. So which one doesn't belong? Here I have two lines intersecting. Woo! Here two lines intersect and they intersect at a perpendicular angle. Here two lines intersect and this angle is equal to that angle. Well, if a whole line is 180 degrees and I break that into two equal angles, they would both, they're both 90. So those are the same. Cool. And here, K and N, they're perpendicular, so I can make that mark or I can make that mark. So really, A doesn't belong, right? Because they're just two lines that intersect. We don't know anything about these angles. We might say, but they look perpendicular, but in geometry you can never prove something through looking at it, okay? All right, moving on. So lots of lines, images for launch. So here it looks like I have an isosceles triangle because these two are equal. Therefore, the two angles are equal, okay? When the two sides are equal, we know that the two base angles are equal. That's just the definition. Diego, Jada, and Noah were given the following task. Prove that if a point C is the same distance from A as it is from B, then C must be on the perpendicular bisector of AB. That means like I could draw any point, and as long as these are equal, okay, they're going to be on the perpendicular bisector. Let me erase that because we don't want to do that yet. All right. So at first, they were really stuck. Noah asked, how do you prove a point is on a line? Their teacher gave them the hint. Another way to think about it is to draw a line that you know C is on and prove that line has to be the perpendicular bisector. Okay, they each draw a line and thought about their pictures. Here are their rough drafts. So Diego's approach, I drew a line through C that was perpendicular to AB and through the midpoint of AB, and through the midpoint of AB. That line is the perpendicular bisector of AB, and C is on it. So that proves C is on the perpendicular bisector. Okay. I'm not sure about Diego, but let's move on. Jada's approach. I thought the line through C would probably go through the midpoint of AB, so I drew that and labeled that point D. Triangle ACB is isosceles, so angles A and B are congruent. Oh. Oops. Sorry. Pen issues. Oh. Jada. Okay. So she just said these are congruent. Triangle ACB is isosceles, so angles A and B are congruent, and AC and BC are congruent. And AD and BD are congruent. Because D is a midpoint. She made it that way. That made two congruent triangles by the side angle side triangle congruence theorem. So I know angle ADC and angle BDC are congruent. ADC, I need a different color. That's this angle right here. So we know those are congruent. And BDC are congruent because of CPCTC. I still don't know if DC is the perpendicular bisector of AB. So she proved everything's congruent, but she doesn't know if it's a perpendicular bisector. Noah's approach. In the isosceles triangle theorem proof, Mai and Kieran drew an angle bisector in their isosceles triangle, which we have right here. So I'll try that. I'll draw the angle bisector of angle ACB. Cool. The point where the angle bisector hits AB will be D. So triangles ACB and BCD are congruent. ACD and BCD are congruent, which means AD and BD are congruent. AD, BD. Oh, why don't we get a marker sometimes? There we go. Those two are congruent, so D is a midpoint, and CD is the perpendicular bisector. I'm not sure. We know he's isosceles, so we can say that. We can say this. So I can prove the triangles are congruent because of side angle side. Therefore, AD is congruent to DB because of CPCTC. But I'm not sure about perpendicular bisector. Okay, we're still trying to prove that. So with your partner, discuss each student's approach. What do you notice about the student? What do you notice that this student understands about the problem? So I think we're going to go through each one and just discuss it just a little bit. So let's go talk about Diego. So Diego's approach. If we look at this, so it's good that Diego knows what being a perpendicular bisector means. How do you know that the perpendicular bisector will go through C? So perpendicular bisector So how do you know the perpendicular bisector will go through C? And how do you know that the line from C, through the midpoint of AB has to be perpendicular? That's my feedback for Diego. Now Jada. Okay, sweet Jada. I'm going to erase the stuff so that we can talk about Jada. Jada's going to be in blue. So Jada, it's good that we thought about side angle side, because that's what we did. Congruence theorem, and we showed we have two pairs of sides and one pair of included angles. So this is good, and this is good. Could you show that angle ADC and angle BDC are right angles? Ugh, I'm off the paper, so it doesn't like it. Because they add up to 180, right? So first she did that midpoint, and then we know it's isosceles, so A and B are congruent. AC and BC are congruent because it's isosceles, and AD and BD are congruent because she made the midpoint. So we did side angle side. That made two congruent triangles, so we know angle ADC and BDC, ADC. So she knows these are congruent, right? And what we could do is say, I'm actually going to, let's do this. Angle 1 and angle 2, angle 3 and angle 4. What we're saying is angle 1 plus angle 2 equals 180 degrees because they're vertical angle, or sorry, because they're a linear pair. All right? And then I can say that angle A plus angle 1 plus angle 3 equals 180 because of the triangle sum theorem. And then angle B plus angle 2 plus angle 4 equals 180 because of the triangle sum theorem. And then there's some actually pretty fun algebra that we can use to get to the fact that angle 1 and angle 2 are equal. Let's see. I'm going to add, this might blow your mind, I hope it doesn't. I'm going to add these two equations together using some algebra. So angle A plus angle B plus angle 1 plus angle 2 plus angle 3 plus angle 4 equal 360. Okay? I can take out those equal 180. And I have angle A plus angle B plus 3 angle 4. No, that's not going to get us there. All right, I think I'm going past the scope of this lesson. All right, but that is the way to prove it, and we're going to get to it when we do proofs with parallelograms in a bit. All right, so if I could rewind and delete that out of this lesson, I would, but it's okay. I don't want to confuse you more than help you. So that's what we're talking about, Jada. Let's talk about Noah. So in Noah's approach, let's see what color haven't we used. Let's go green. It's really good that he thought about using congruent triangles. What congruent triangles did we use? Side angle side? Yep, right there. Side angle side. Which triangle congruence theorem can you use? We already did it. So side angle side. But the question is, how can you show that CD and AB have to be perpendicular? Okay, that's the challenge of it, right? Okay, that's the challenge. So let's go back to the questions. Using the ideas you heard and the ways you think each student could make their explanation better, write your own explanation for why C must be on the perpendicular bisector of AB. And let's go ahead and use this drawing right here. We're going to write a very nice little proof using the book's paragraph and make it into some nice columns. So here, we're going to draw the median CD, A, C, B. I can't use that one. I need to use this one. Okay, let's just start here. So let me draw that triangle. I'm going to make sure I get it in the right order. I don't know what's going on in my house now. I hear screaming. So this is A, B, C. Now the first thing we're going to do is draw the median CD. The median, the definition of median is it goes from the vertex and it bisects the opposite side. So and that is just a construction. Now we know D is the midpoint of AB because it's the definition of median. And again, here are my statements and here are my reasons. It's a two-column proof. Since D is the midpoint of AB, segment AD is congruent to DB. And again, definition of median. Since AC is congruent to CB, definition of isosceles, ACB must be an isosceles triangle. Yep. Angle B is congruent to angle A. Definition of isosceles. Therefore, by side angle side congruency theorem, I can say that triangle ACD is congruent to triangle BCD because of side angle side. Now, because those are congruent, we can say that angle ADC is congruent to angle BDC because of CPCTC. And that's this angle, ADC and BDC. Ah, they're congruent. This is why. We're there. We're going to go B, or blue, golly. Now, angle ADC plus, or and, angle ADC and BDC are a linear pair. And that's definition of linear pair. This is it. I'm excited. Are you excited? So angle ADC plus angle BDC equals 180 degrees. Definition of linear pair. And since they're equal, I can actually substitute. I can say, all right, well, fine. Then ADC plus, I'm going to substitute BDC for ADC equals 180. 2, now I'm collecting like terms, like in algebra. ADC equals 180. I just did like x plus x is 2x. And now I can divide both sides by 2, and I can say, I'm totally out of space, ADC is 90 degrees. And this would be, this reason right here is linear pair. This reason is substitution. And then I'm just collecting like terms. And then I'm dividing. All right, so once we said that ADC was 90, we can actually put that back up here and say, okay, since ADC is 90, then AB or BDC substitution. That's my dog snoring. So we just did it. Okay, that was a longer proof. That was pretty difficult. But once we said that they're both 90, then we know that CD is a perpendicular bisector. Because it's perpendicular, it meets it at 90 degrees. It bisected AB into two equal pieces. We already said that. Life is grand. Okay, but that was a lot. Okay, that was a lot. All right. So again, we could do that with this one too. Those are equal because it's isosceles, so this bisects it. That's equal, therefore those angles are equal, and if I add those angles together and divide by 1, or an equal 180, etc., we're good. Here, what's cool is here I can make an isosceles triangle, right? Because that's a radius and that's a radius. So there's an isosceles triangle, and we know that's perpendicular bisector too. Okay? Which really, if I label this as C, the triangle inside of there is really that one. Okay? Whew, that was tough. All right, work on your own to make a diagram and write a rough draft of a proof for the statement. If P is a point on a perpendicular bisector, prove the distance from P to A is the same as the distance from P to B. So we want to prove that this distance and that distance are equal. And we could do that by saying, let's call that Q. AQ is congruent to BQ. It's It's kind of given because it's a perpendicular bisector. Angle, nope, PQA is congruent to angle PQB because they're perpendicular, and then PQ is congruent to PQ because they're the same, because they're reflexive. And we just did side, angle, side. Side, angle, side. So I can say that the triangle APQ is congruent to BPQ. Why did I do that? I say them one way and write them a different way. BPQ because of side, angle, side. And then AP is congruent to BP because of CPCTC. Okay, so we just did it. It said prove the distance from P to A is the same as B to A. And we did that using CPCTC. Right? That was a little bit easier, not gonna lie. All right. And that's really what we did here, except I labeled that Q. Cool. Okay. That's it. Another tough lesson, but so important. Proud of you.